Welcome. Today's lesson is about solving triangles using the Pythagorean Theorem. I have two examples for you. One is a very simple one, and then one that takes a little more thought. The first one, you are to find the missing length of this right triangle. We know the hypotenuse is 8, and one of the legs is 7. We're looking for this missing leg. We substitute in the Pythagorean Theorem. A squared plus b squared is equal to c squared. I place the hypotenuse first, so I have less chance of making an error. The hypotenuse is 8, that's c, and then the two legs are interchangeable. I've called this one a. So I have 7 squared plus b squared is equal to 8 squared. Simplify, 49 plus b squared is equal to 69. Combine like terms. That means I've got to move this 49, so I subtract 49 from both sides. Here's my zero pair. Leaves me with b squared is equal to 15. Then I have to take the square root of both sides. And my final answer is b is equal to the square root of 15. If you can simplify this radical, please do so. This one is already simplified. The next problem is a little more complex. You're told to find segment AD. You're given this triangle, and you've got an altitude here. This is a two-step problem. The first thing you need to do is find the altitude, BD, and then once you've got the altitude, then you can find the missing leg here, AD. To find BD, substitute in the Pythagorean Theorem. So we're using this part right here. The hypotenuse is 17, one of the legs is 9, and I'm looking for segment BD. Put it in parentheses, that way you know that it's a segment and not the product of two variables. Simplify, gives me 81 plus the segment BD squared is equal to 289. Combine like terms, so I subtract 81 from both sides, gives me segment BD squared is equal to 208. So I take the square root of both sides, and the square root, well, then I have to start breaking down into prime factors. I know that this 4 will go into it, so it's 56 times 4, and I see that I can break this 56 down into 13 times 4, times this 4 here. Now I've got a pair of 4s, so the square root of 4 times 4, 16, is 4. So I pull one of these 4s out in front, drop the other one, and my final answer is this segment length is 4 times the square root of 13. This is the simplified answer for this. That's first step. Now I need to find this. So I do the Pythagorean Theorem again. The hypotenuse is now 16. I'm looking for AD. And this leg is 4 times the square root of 13, that whole thing squared. It must be inside the parenthesis. I know this squared is 208. I've already worked that problem, so that makes it easy for me here. 16 squared is 256. Subtract 208 from both sides. Here's my zero pair. And I have segment AD squared is equal to 48. Well, the square root of 48 is 16 times 3. 16 is a perfect square. It's 4 squared. So I can factor out a 4, and I have the 3 left under the radical. So segment AD is equal to 4 times the square root of 3. Please go to Edmodo, find lesson 3.31, and complete the check for understanding.